We're going to solve the last 5 problems on this 1988 AP Calc AB multiple choice. We left off on number 40, so let's begin. This shouldn't be too long of a video unless the problems are difficult. We'll see. Okay. 40. The sides of the rectangle above increase in such a way that dz dt is 1, dx dt is 3, dy dt. At the instant when x is 4 and y is 3, what is the value of dx dt? This is a related rates. How can we relate x, y, and z? It's a rectangle, so we know that we can use Pythagorean theorem. X squared plus y squared is z squared. Let's differentiate with respect to time. 2x dx dt plus 2y dy dt is 2z dz dt. Okay? Do we want dx dt? We need x. They give us x, they give us y. dz dt, dx dt is 3 dy dt. Okay, so I think they give us everything. So let's start plugging in. They want dx dt. So it'll be 2 times x is 4 dx dt plus 2 times y is 3. They give that to us. dy dt is 1/3 of dx dt. Let me write it like that. dx dt is equal to 2 times, what's z? Oh, we need to find z. That's easy. This is a 3, 4, 5 triangle, so that's easy. If not, if you don't know that, you can just use the Pythagorean theorem. 16 plus 9, that's 25. Square root of 25 is 5. Okay? dz dt is 1. Okay? So let's solve for dx dt. These would cancel. This is an 8 plus another 2, that is 10. dx dt is equal to 10. So dx dt is 1. 40b. 50%, oh, that's pretty good. 50% of people got that right. I was surprised, because usually relate rates is, I would think, one of the more difficult problems for people that don't understand the concept very well. But anyway, this one, probably this is a low scoring one because of the 3 choices. If limit as x goes to 3, f of x dx is 7, which the following must be true. Is it continuous at x is equal to 3? Well, we don't know what, remember definition of continuity. Limit of as x goes to 3, of x has to equal to f of 3. We don't know what f of 3 is. Is f of 3 7? If it is, then it's continuous, but we don't know. And that's 3 also, we don't know. F is differentiable at x is 3. Just because the limit exists doesn't mean differentiable, because we just said it might not be continuous. Okay? If it's not continuous, it cannot be differentiable. So I believe 41 should be it. Yes. Only 30% of people got that right. And 21%, oh, I'm surprised not so many people omitted this. 11% omitted. 21% picked E. So I just explained. We don't know if it's continuous. This is definition of continuity. Okay, so we eliminate this. This also can eliminate this. We don't know if it's differentiable. If it happens, we don't know if it's continuous. If it happens to be not continuous, then it's automatically not differentiable. So, A. Graph of which of the following equations has y is 1 as an asymptote. Okay? Y is 1 as an asymptote. This has a vertical asymptote, so no. This is not an asymptote. There's no asymptote here for sign, because it's just bounded by 1, but it's not asymptotes because it does touch 1. So no, not that. This is a vertical asymptote, so no. There's a slant asymptote for here. Actually, no. This one, this is slant asymptote, so no. This one is a horizontal asymptote at y is 0, so no. This actually, there's a vertical asymptote, but there's also a horizontal asymptote, my bad. Because remember, there's a rational function, we can do the degree test. They're the same, so take the ratio of the leading coefficients, that's 1. So there is asymptote 42C. Okay, so only 56% of people got that right. Okay, next, volume of the solid obtained by revolving the region enclosed by the ellipse, this guy, about the x-axis is, okay. How does this ellipse look? If you don't know how it looks, well, you can write it in standard form first, if you do know. Okay, so we know that it's centered at 0, 0. Okay. And then if I remember correctly, this should go 3 on this side, 3 here, and then y is up 1 like this. Okay. We want to revolve this about the x-axis. Okay, so let's just take, can we take half of it? And then rotate it? Let me think about this real quick. Yeah, I think we can split it up. Okay, so let's just worry about the top portion. Okay, so I wrote it in this form because this should look more like the standard form of ellipse. I'm pretty sure they don't expect this for you for AP Calc AB anymore, but it's still a doable problem. But regardless, might be a more challenging one. But as I peeked at what the answer is, only 24% of people got this right. So it is a more tough problem. But anyway, let's focus on the top portion only, because when we rotate it about this axis, if we rotate this whole region, it's the same thing as rotating just half of it. So, okay, so this is a bad sketch, but it's from -3 to 3. Now we rotate it about here, okay, about the x-axis. So this we know how to do when it's just half, because this is our r out. Or there's no r in here, so I'm just gonna let r out. So it's pi integral r out squared dx, correct? So this is pi integral from -3 to 3 of what's r out. It's, well, let's solve this for y in terms of x. So y, can we actually, yeah, let's do this. Y squared is 1 minus x squared over 9. So y is plus or minus square root 1 minus x squared over 9. Okay, so this top portion would be the positive. Okay, so it would be square root of 1 minus x squared over 9 squared. So the square goes away. Okay, and in fact, this is an even function. You can even look here by symmetry, right? From the -3 to 0, 0 to 3, they're symmetric. So we can even do this as 2 pi integral from 0 to 3, 1 minus x squared over 9 dx. It's also an even function, as I said, okay? So this is 2 pi times x minus x cubed over 27. Evaluate from 0 to 3. So that's 2 pi, 3 minus 3 cubed is 27. And then minus 0. So this is 1, which is 2 pi times 3 minus 1, which is 2, which is 4 pi. B. Okay, so not that difficult. You just had to know how the ellipse looks like, which looks like this, okay? And we also realized that if we rotate this whole region about the x-axis, it's the same thing as rotating half of it. Okay? So that's why you focused on this one only. And then with this, we know how to find the volume of with the disk method. Okay? Which is what I did over here. Okay? Let's move on. 2 more problems. Let's see if they're quick or not. Let me just peek at the these are low scoring problems, the next 2. So we'll see. Let f and g be odd. This is probably important. P, R, and S are non-zero functions, which must be odd. Okay, I can see why it's a lowest scoring one. Because even I don't know of a quick way to do it off the top of my head right now. So obviously I'm just going to let's think of a counter example to disprove any of these. Okay? If I think of an example that can make one of these even, then it's false. Okay? So let's see. I already can think of one for this. If f and g are odd, so x cubed times x cubed. Okay? It doesn't say that f and g are different, or even if they are, like x to the fifth. These are both odd. If we multiply them together, that's the same thing as x to the eighth. This is even. We eliminate 3 already, so we eliminate this, okay? So how about f of, actually there's a, so you can think of a counting example like this. Since it says odd function, we know how to prove if something's odd actually, okay? So it's quite easy, because remember odd function, if, let's call it a of x, okay? If, let's write this. A of negative x is negative a of x. It's an odd function, okay? So let us do that for this first one first. So let's do it up here. So 1, lead broke. 1, okay? If f of g of negative x. G is odd, so it becomes f of negative g of x. Okay? So, since f is also odd, this is just minus 1 times g of x. Okay? So, it's similar to here. We can do, it'll be negative f of g of x. So this is true. How about this one? So number 2, f of negative x plus g of negative x. This is equal to negative f of x minus g of x, which is equal to negative f of x plus g of x. Okay? This is negative of this. So it's also odd. Okay? So it should be C. 44. C, yes. Okay? Last one. Volume of a cylindrical tin can with a top and bottom is to be 16 pi cubic inches. So V is to be 16 pi. If a minimum amount, this is an optimization problem, minimum amount of tin is to be used to construct the can, what must be the height of the can? We're trying to minimize the amount of tin, which is the surface area. Okay? So what is the equation of the surface area of a cylinder? Okay? What would that be? So if surface area is S, what's the equation? Hopefully, if I remember correctly, is like 2 pi r squared for the top and bottom circles of the cylinder plus 2 pi r h. Okay? We're trying to optimize this. So we want to get it into one variable, so we probably need to use this guy. What's the volume of this cylinder? Is pi r squared h. Okay, so these can cancel. So h is equal to 16 over r squared. Okay, so we can rewrite s as 2 pi r squared plus 2 pi r times 16 over r squared. So we can simplify 2 pi r squared plus 32 pi over r. Okay, I believe that's right. So we're trying to optimize this. Let's differentiate. S prime is equal to or ds dr specifically is, so here would be 4 pi r minus 32 pi over r squared. We set this equal to 0 to optimize. Let's make this fraction go away. Let's multiply by r squared on both sides. So 4 pi r cubed minus 32 pi is equal to 0. Okay, so let's factor 4 pi. Or we can even factor 4 pi, that's fine. R cubed minus 8 is equal to 0. So r cubed needs to be equal to 8, meaning r is equal to 2. Okay, this is the radius of the cylinder. What are we trying to find? We're trying to find the height of the cylinder, so we can plug it into here. H is equal to 16 over 2 squared, which is 4, which is equal to 4. Okay, so 45 hopefully is D. Let me check. 45 D, yes. Okay, this is the optimization problem. Okay, so that's it for this one. By the way, 43% of the people got this right, so I'm surprised for that. I thought it would be even lower than that, but that's good. 37% of the people got this one correct. Sorry, it's cut off. This one correct. Okay, so that's it. Hopefully this was helpful. Please give it a like if it was, and please subscribe to the channel to look out for the next video.